This is Module 6, Lesson 9. Generate two number patterns from given rules, plot the points, and analyze the patterns. We're going to start with the rule for a line. The rule is y is 2 more than x. Whatever x is, add 2 more and you'll get y. So if x is 1, y is 3. If x is 1, y is 3. To complete our chart then, if x is 5, y is 7, x is 10, y is 12, and x is 15, y is 17. We've plotted those points on our coordinate grid and made line L using that rule. Y is 2 more than x. Let's see if we can determine the rule for line M. We had points 0, 5, 5, 10, 10, 15, and 15, 20. Our rule for line M would be that y is 5 more than x. Whatever x is, add 5 and we get y. So we have two lines now. Line L, where our rule is y is 2 more than x, and line M, where our rule is y is 5 more than x. These two lines are parallel. They move along, they will never intersect. The only difference is that line M is a little farther up on the y-coordinate grid than line L is. And that makes sense that it would be, because for line L we had the rule that y is 2 more than x, but on line M we had the rule that y is 5 more than x. So it makes sense that it would be farther up on the y-axis. Let's think about a line N where the rule is y is 8 more than x. We would have points 0, 8, 3, 11, 10, 18. We notice it's still an addition rule, but this time we're adding 8 to the x-coordinate. I think I could make a prediction that this line will also be parallel to the other two on our coordinate grid. But I also think it will be higher up than line L and M, because this time there's a difference of 8 between the x-coordinate and the y-coordinate. We had a difference of 2, we had a difference of 5, and a difference of 8 is going to put it farther up starting on the y-axis. So here we've plotted our points for line N, and just as I predicted, it is parallel to M and L. The rule told us, though, that we're adding 8, so it is farther up on that y-axis. If I had a rule that y is 10 more than the x-axis, it would be parallel to the other lines as well, and it would be higher up still than any of the lines we have so far. The rule for line P says that y is x times 2. So if x was 2, 2 times 2 would be 4. If x is 0, 0 times 2 would be 0. If x is 1, 1 times 2 would be 2. We would have 3, and 3 times 2 is 6. And we could have 4, and 4 times 2 is 8. So this rule says that y is x times 2. X times 2. In this picture we've plotted those points for y is x times 2, and this is what our line would look like. We'd have 0, 0, we'd have 1, 2, we would have 3, 6, we would have 4, 8. This is our line for y is x times 2. Here we're adding another line where the rule is y is x times 3. So we have 0, 0, 0.13, 3, 9, 4, 12. Y is x times 3. This is that line plotted on our coordinate grid. As we look at the two lines, we see that they intersect at the origin at 0, 0. We see that line Q is steeper than line P. It goes up at a steeper angle, And the reason for that would be is we're multiplying our x times 3 each time. So it increases at a greater pace than the one where we multiplied x times 2. Here we've created one more line and naming it line R. Our rule is y is x times 5. We have 0, 0, 3, 15, 4, 20. Y was x times 5. This line, again, goes through the origin. It intersects the other two at 0, 0, but it is steeper yet than either Q or P is. The reason for that is our y-coordinate is jumping up 5 times whatever x is, not 3 times, not 2 times, but 5 times. So it is going to be a steeper line than our other two were that we created. If I wanted to try to create a line that is not as steep as this first line that I made, not as steep as P, where y is x times 2, I would have to have a rule where y is x times something less than 2. Maybe y is x times 1.5, or y is x times 3/10. Anything that's less than 2 would create a line that's not as steep as line P is.